Do 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 do. Bow 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 bow. Someone complained of my music, so I have no music. Very boring without music. It just means I gotta talk to myself more. Hopefully everyone hears me okay. My one viewer, which probably really isn't a viewer. It's probably a bot. Oh, 3 viewers. Uh-oh. I got viewers. Are they the chatty type or are they quiet type? Anybody want to guess what I'm hacking today? Look, I added another camera. Fortunately, I did order some stuff, but Amazon is stuck in some kind of shipping loop, and I can't hook up my other microphone. Well, I can, but it's going to be like laying right here. It's not going to work very well. So I was going to hang it so it was down like this. This is a better microphone, but alas, Amazon no deliver. So you get crappy microphone. Cleaning out my desk here so we can reverse engineer and program and get some cool looking displays going here. So the idea is these are pulled out of some displays. I have a bunch of them. The goal will be to reverse engineer the schematic on the board and then figure out how to drive them with an Arduino. But before I use an Arduino, I'm going to use this fancy tool sitting next to me. It is a pattern generator. So hopefully we can use it to generate the pattern, but first we have to figure out the schematic. So what I'm doing is cleaning off the table here because there's a bunch of small, sticky, icky stuff on here from my last whatever project I had on here. Alright, let's see if we can get some better camera view here. Let's try this view. Let's see if that does any better. Lighting kind of sucks for it. Alright, let's see if we can do this. Turn this like this. And see if we can put this down here like so.
Hi.
So the panels are going to be used for displays. Can't tell you that part. That's a secret. But I have a ton of them. The idea is to use them as score displays. They are old. Yes, I could probably buy some better score displays online. Yes, I could do this, but it's called upcycling. So I don't need all these sitting here on my desk. Put those up here. So, first thing we're going to do is we're going to figure out what power is. So we have 3 wires going in down here. And these are all out of, in the U.S. they have maybe in other countries, they in the Department of Motor Vehicles, where you get your driver's license, they had these big Q signs that said, now serving A104 at window number 3. So, this is the letter section of that sign. I have about 100 of these. I bought them all at an auction. I literally have a metric ton of display modules. So they had proprietary 8051 CPUs that had encoded ROM that was write protected. Didn't really want to figure out reverse engineering the protocol. So, yes, FPF. They will be used at something at FPF. So, we're going to figure out how to drive these from an Arduino or my pattern generator, which is sitting next to me. Pattern generator will be easy because we can easily set up a waveform to send in here. This might be pretty straightforward. This could be a complete disaster. Let's hope not the latter. So instead of my traditional stream where I am fixing something, I am going to reverse engineer something. So, without further ado, the first thing you need is what's called, it's probably the most advanced technology ever created in man, and everyone has one. If anybody can guess what it is, I will pat myself on the back. So if anybody can guess, see if you can guess. Before I figure out where mine's at. As I run over my cords and stuff on the floor. Nope, it is a pen. Very important. a writing utensil. What do you think the second most important thing is to have? You know, if it's a pen, it's got to be something to go with it.
Pie.
Nightbot. Paper! Yes. Paper. Alright. So, when you have a device that has no friggin' schematic, first thing you do is you want to sort of draw it out. Got to get you an idea of what's going on here. We got a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got a 20 pin header. So we'll just draw our 10 pins, and we have some power wires down here. We got red, black, orange, and then we have 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's an 8 by 16 matrix. No, we don't need any of that crap. Paper and a pen. That's all we need. And better glasses. I don't need my glasses to see this. All right. So first thing we're going to do is get an idea. Try to look at the traces on the back of the board. So we can see that all the LEDs in a column are all tied together. So, and then they all go through some resistors, and looks like they all go to a ULN 2803. So we've got a ULN 2803A, a resistor, and then column common. I don't know if it's the cathode side or the anode side yet, so don't really give a crap. That'll be determined by the chip. So I'd look up the 2803. 2803 is actually a commonly used chip in Williams pinball machines. It is the column driver. So it is usually an 8 output, which conveniently we have 8 rows. Yep, just like a light bright. So 8 outputs of the 7803, which we conveniently see that all the inputs are tied to a 74 HC574. So the H74 also looks like, interesting enough, so now we have a 2803 here, which also looks like it ties to column data. Maybe? Alright, so I think, okay, so interesting. I show 8 going to this. Oh, okay. So we have two 2803s, and it appears one 2803 maybe driving the column, the rows? Which is confusing because, okay, no. I got this wrong. Wait a minute here. This is making sense. They have some BC33 transistors sitting over here. If you hold it up to the light too, you can also help figure out where all the traces are going. So these 8 transistors here are also tied in to each row. Okay, these resistors are not tied into the row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Let me back up here. So the two ULN 2803s, the outputs are driving the column, or the rows, this way. So they're driving the rows. These transistors here are being driven by a HC573. So 74 HC573A is driving what appears to be the transistors, which then go to the rows, or the columns. Now, the inputs of the 573 appear to be parallel loaded from here. Both of these are driven by the 574s. So what I'm thinking is this row is latched, and then the data is latched, and then we latch the next row, and we latch it, and it's strobed in this fashion. So we're going to have probably a horizontal clock. Maybe, I don't know, let me look at what a 573 is. Where's my book? Alright. The other thing that's always good to have is a big, thick book. This book can be used to be thrown at somebody that asks a stupid question, but unfortunately, I can't throw it at the screen or break things, so I won't be throwing it at any of you because there's no such thing as stupid questions. Alright, let's look at the 573. Let's do the 573 first, and then we'll look at the 574. Unfortunately, I can't remember all these off the top of my head, and this book seems to skip over 573. Must be newer than this book. We look in the front of the book. '74 573. All right. So this book is from 1988. Apparently, it's too old. So we'll have to use Google's. Unfortunately, I can't share this screen with you. Sorry. Alright, so the 573 is called a octal D type flip-flop. Octal meaning 8. Has 3 state outputs. So pin 2 correlates to 19, pin 3 correlates to 18. So it's pretty much in and out. So if you look at this chip, pin 1 is output enable, pin 20 is power, pin 11 is LE, pin 10 is ground. So we're going to go ahead and write that down. 573, pin 1 is output enable not. 2 through 9 is input. 10 is ground, which is a given. 11 is LE. It is not an not signal. And 19 through 12 is out. And VCC is 20. So, latch enable is an active high. So, when the output enable is low and latch enable is high, so we're going to write down the truth chart because I'm not going to come back here and look at this again. Output enable, not, so we have L, 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 H. And then we have latch enable, which is H, H, L, X. And data, high, low, X, X. So this output is high, low, Q, O, and Z. So when output enable is high, the output is floating. When the output enable is low, if latch enable is high, D equals O. When this is high, low equals out. When L is latch enable is low, it's whatever it was latched at. So basically we will hold output enable low. We will then load our address on the data bus, and then we will briefly pull latch enable high, and then that'll latch the data to the output. So we do, first pin is do data. Then we want to do latch enable. 3 output enable. All right. Let's just make sure I got that right. Pretty sure. Good on the timing chart. They conveniently don't show the timing chart. High-speed octal latch buffered common latch output enable the buffer common output enable pins. This device is functionally known as 74373 but has different pinouts. Input and outputs on opposite sides, package allowing easy interface. Useful as an input or output port for microprocessors. Functionally identical to the 74LS373. Input clamp diodes, speed termination effects. Fully TTL and CMOS compatible. Basically, I need to look up the 373 in this book because they don't give me, this diagram doesn't give me anything. I'm pretty sure the 374 is the same as this one. The 373, go here. I'm pretty sure I can latch. Yeah, so 373 has, yeah, so output enable latch. So the output enable, we look at the schematic here, or the functional diagram of the chip. My apologies, let's just switch over to this view here. We'll zoom in a little bit. So the output control register, right here, works independently of the flip-flops. So that goes that we can load these up with our value, and then we pull this high or low. So basically, we would load the column that we're working with, Now the only thing is once we load this, which column we're working on, the previous column is cleared. So we can't have the output enabled and load the data. So we have to load the data, latch it, output it, turn it off, and then go the other way. So what that means is we're going to do the columns last when we latch. So we're going to most likely going to load the data into this serial bus, which is these 16 lamps, and then we're going to strobe the column on and off simply by pulling the output enable high then low. Now we can go real slow or we can go real fast. So we're going to have a persistence of vision, which is basically the frequency that we just scan it at. So if you control the brightness is how long that line will stay on, so forth and so on. So we're gonna first we got to figure out how to load the data, which is going to be pretty easy because the 573 is straight through. So we can actually just hook a ohmmeter here and then figure out which pins they are. And I'm betting it's going to be something super simple. 574s. Look up the 574 and see what the 574 looks like. I'm pretty sure the 574 is got a clock input. Yes. So the difference between the 573 and the 574 is the 574 is a D-type flip-flop, which basically has a clock pulse. I don't know why they use this one differently. I don't know why. It's basically the same chip. What? The 573. Of course, that didn't have a functional diagram on it. Let's try this one. So the 573 has a latch enable. 574 has a CP. Output enable is again tied to the output. Again, we're using parallel data again. So we're going to parallel data in, and then why? So these ones latch data on. So we're going to set data, then we're going to CP from low to high, and it's going to latch the data when you do that. And then the output enable. Pin out is, pin 1 is output enable, which is the same as this guy. And clock pulse is 11. So it's theoretically the same exact pinout. The only difference is this one's using diode on the clock post, 573. This is on a drawing. See. Yeah. This is a knot on the clock pulse. It's backwards. It's basically the same damn thing as this. The difference is here they're calling it a clock. Here they're calling it a transparent latch. It's literally the same damn thing. Alright. Alright. We're done with the book. Time to start figuring out which pins go where. We still haven't figured out the power yet. Alright. So this is an input. Gee, that's a shocker. How about I put this in BP mode? Alright. That goes there. That goes there. And then that goes to helps if I've actually picked the base. That goes to this collector here, which goes to the first row. So this is data for column 0. Helps if I go to the next one. Data for column 1, we can just confirm that. We'll go here, the base of this guy, which goes to this guy here, right? Okay. This one. Alright, we're just going to go right on down the line here. Alright, so there's our data for the columns. Now we need a latch input, which is going to be, we have this guy here. So this is a CP for the column. And then now we need to output enable. Which is stuck high. So the output enable is always high. So on the column, output enable is always tied high. Well, that means we never have to worry about messing with that pin, which kind of sucks because we have to load the data pretty darn quick. Alright, so we have these 7 pins unidentified, and we have 3 open pins. Now, I'm pretty sure these are going to be tied together. So they multiplexed. So this is going to be row data 0 through row data 1, but it's also going to be 0 through 7, sorry. It's also going to be 8 through 15. So we have, this is our latch. Oh Jesus! Seriously? Great. All of the latches are latched together. So we have to load all the data and then call the latch, which sucks. So now we have 3 open pins. So I'm guessing one of these. Are they tying nose high too? Okay, so the good news is so this is output enable for 0 through 7. This is output enable, output enable 0 through 7, output enable 8 through 15, or vice versa. This guy is no connect. Nope, sorry, that's probably ground. Let's just confirm that. Nope. All right, that goes to something. That goes to this orange wire. The orange wire does not apparently go to anywhere else. This wire here is also tied to ground. I said that was the clock pulse. Are they grounding the clock pulse? They're grounding the clock pulse. Alright, so not exactly sure how you're transitioning. Nope, that's the output enable. Yeah, output enable is tied low. This is ground, so this is actually ground. This is logic 5 volts. And these are not output enables. So latch input on this 11. So
Hi.
just off sub screen. Oh, I'm reverse engineering an LED display. So I basically, you've missed all the fun stuff of me tracing out all the pins, and next I will need to work on figuring out the way to drive the logic, and I'm going to use my pattern generator to drive the logic, and then see if I can get something to light up on the display. And then after I do that, I am going to attempt to maybe use an Arduino, or maybe I'll just use an Arduino. I'll have to make a font. So let's see here.
Hi.
Yes, the pattern generator is very similar to a signal generator. But generates logic. I can generate, I think, 64 lines of logic at up to 300 megahertz. I will probably run it at 1 megahertz and see what I get out of this. It might be too fast. I wish it was a way to easily type in the value. But the good thing is I could take 1 megahertz and divide it in half by just basically doubling the same row more than once. So these are output enables. U and U. This output enable is always tied high, and its output is always tied low. So the good thing is, so what we'll do is the order of display will be pull DC 0 through DC 7 low. This will basically drive all the rows off, or all the columns off. Next step will be to load rows 0 through 7 into RD 0 through RD 7. Latch OE 0 7. Then we're going to, so we're basically going to go high and then low. Then we're going to load rows 8 through 15, again through RD0 through RD7, and then we're going to latch output enable 815, high then low, and then we're going to set our DC0 through DC1 high. So pick one, hold high. Make sure Hammy knows we run into those at auction sometimes. Yeah, so these all actually came from an auction. I got about, of this model I have 6 more of these, but I also have a ton of larger LED modules. They're not super large, but we only need 6 of these for the project. So I figured I get these 6 figured out, I then can pull the 6 out of the other module. And I also have, I keep hearing weird noise over here. I actually have the other portion of this display. This tied into here like this. So you had A124, B blah blah blah. The downfall is, like I said originally, it has this custom controller chip. It just says Qmatic 32.08 on it, made by Intel. It's most likely mask ROM inside it, and it was probably burned at the factory, mass produced, and that's about it. Basically, this plugged into this end, and it supported plugging in more, but the modules I have don't plug in, don't have anything that plugs into them. It's just that. And then they also had apparently models where they plugged in going the other way as well. One processor controlled everything. But not much I can do with it. So these ones I'm probably not going to worry about. Yeah, but basically I don't care about this module. Because this is way too much effort. You can just buy big jumbo LED displays that we could use for this. No big deal. I mean, but I figured these ones here are way cooler because they're all dots. You can't really buy a jumbo LED module this size. I do need to figure out the power situation going on here. So this red wire here is being used as the collector on all these transistors. So that is to be driving that. So what I need to do is alright. Pod 5, Pod 2, Pod 4, Pod 3, Pod 6, Pod 5. There's 2. Make sure I install the TTL pod. Alright, that's that pod. So this gives me 7 data pins. And I need to get, so I'm going to do this, will give me 7. So that'll work great. 7. And then I'm going to need 1 more. These will be, this one will be all my control logic. This will be my, so columns, rows, control logic. Only got 2 pins for control logic. Alright. Alright, there's our data pods. So those will all hook onto there. Magically. Poof! Yeah, I could breadboard it, but why would I do that? Because I can just plug all these. This is paid as pin 0. Just plug that right on there like that. Look at that. Is that not awesome or what? I will have to hook up a ground wire, but that's basically how I can do that. I'm going to turn this thing on. Hopefully it's not too loud. While that's booting up, I'm going to get a drink, and then we're going to switch over to my desktop view, and we're going to load up the software for the pattern generator and try to set this up. We're going to have to probably draw some more stuff out to get an understanding. I'm just going to try to light up a whole, like every other light in a row, and then just basically go like that, and it's just going to be every other line. So that'll be the goal to do with the pattern generator. I have never actually used the pattern generator to do this, so I look forward to doing this. This is going to be fun. So I don't think we need to run the pattern generator at the full 300 megahertz. Probably a little bit of overkill. So I'll be right back. I'm going to get myself something to drink. This thing's about booted up. All right. Switch over to desktop view. How about we put the camera so we're looking at this camera here. Switch microphones. Hopefully not too loud for you guys. All right. Let's load up the software. Desktop. Streaming stuff. All right. We don't need these two modules, so we'll be working in this module right here. All right, this pod, we're going to rename this bus. So we're going to name this column data. And we're going to add row data, right? Yep. And then we're going to add control. Okay. Oops, don't need that bus. This is 8 bits wide, and this is just 2 bits wide. All right. We're going to switch these two around. We'll make this one row. Yeah, whatever. Ah! Hopefully it's not too loud for you guys. All right. This needs to be row. Make this one row data. Column data. Well, no. Let's do it this way. Column data. Control. All right. Clocking, internal. We're going to go as slow as possible. 100 megahertz. 1 megahertz. It's probably still too fast. All right. Sequence. Switches all to binary. All right. So this is the column. No. Man, signaling. All right. Column data is 8 bits. Control is only 2 bits. Yeah, so the goal here is we'll basically I'm going to write the row data first, which is we're going to do 0 1 0 1 0 1 0 1. And then we're going to repeat what was done before, raise it, repeat what was before, zero it. This we don't care. So this will latch the first 8 bits, and then we're going to copy this, and we're going to latch the next 8. And then we're going to latch. We're going to output 1 column data. Now, we'll copy this a couple times. And then we're going to go back to 0. Now we'll repeat the whole thing. And I don't know what I did wrong here. And then we're just going to repeat this pattern. But this time we're going to latch. Yeah, so basically what I'm doing here is I am manually outputting the data on the pins on the output of the logic analyzer and or on the pattern generator. Basically so 0, 0, 0. So we go load the data, latch it, turn it off, load the data, latch it on the next pin, turn it off. We're not going to do any latching, but we're going to output column 4. Then we're going to repeat the same process. And then we're going to use the next. So what I could do, I could do a macro. Do alternate, and I can do is sequence. I can just copy this sequence and just put that in here. Rawr. interface is not the greatest. It's like Foxtrot, Fox, whatever. Now I could technically have done, yeah, I could have probably made this a little easier. I could have just latched both of them, like using 1-1 instead of doing two separate loops. But the reason I want to do this is, I want to alternate. So this is Alt 1. What I'm going to do is go to Alt this one, and I'm going to copy from alternate to Alt 1, hit OK. I'm going to rename this one Alt 0. And then in Alt 1, I'm going to change this pattern to 1010, 1010, and then 1010, 1010. So Alt 0, Alt 1. Now we go over here to bus or go back to my sequence, and I can take all this out. Are you sure? And I can do is, so this is one thing I don't like about this is you can't call a user defined macro at the beginning of the sequence. I don't know why. You'd have at least two instructions. So you go user defined macro, hit Alt 0, hit OK. And then we can do delete all these rows here. Are you sure? And then here we can go user defined macro, Alt 1, hit OK. Get rid of all this here. And then we can call user defined macro. We'll do Alt 1 again, Alt 0. And so forth and so on. Yeah, I know. All right, so we're going to do a macro. We'll go back over to macros. We're going to add one called column 0. We're going to insert a row. Yes, I know. Insert a row. And the only thing we're going to output is 1, 2, 3, 1. And then we're going to add column 1. Insert. Oh, wait. Go back to column 0. We want to do well, actually, no, I don't need to do that. Column 0, 1 bit. Column 1. Right. Add. Column 2. Insert. 0, 0, 0, 0, 0, 1, 0, 0. Right? All right. Add column 3. Insert. Add column 4. Insert. Add column 5. Insert. Add column 6. Insert. Column 7, which is the last column. And then we're just do column off. Oops, cancel. Insert. And it should just be all zeros. All right. So you've noticed originally I had 4 in here. So what I can do is we're going to do start a loop. And we're going to loop 4 times. And then inside this loop, we can call my user defined function column 0. Now, this one here, we can do another loop. So we're alt 0. We're going to output the column 0 4 times. And now we want to turn off all of them. And delete these 2 rows. Now we want to load up our alternate. And now we're going to do a loop. We're going to loop 4 times. 4 times will basically cut our 1 megahertz to 250 kilohertz. If I turn them all on, then it kind of defeats the purpose. I could just turn them all on and they would just be on and you wouldn't see anything happening. So the idea is to do a checkerboard. So that I can see that I'm actually alternating the data. So instead of me typing every single one of these over and over again, I just created those macros, and I'm just going to call each of those macros, and then those macros. Yeah, I mean, I could. I mean, I want to use the fancy tool. Why can I not use the fancy tool? It's just, I don't have a spare way of just pulling pins high and low. I mean, I gotta. You're killing me, Smalls. You're killing me. All right. Alt 0, column 0. Alt 1, repeat 4 times. Call user define macro. Column 1, hit OK. And then after we call the macro, we need to turn everything off. Off. Like that. Hi, Andrew. Bye, Andrew. Hi, Debs. I see you're out there. I see Andrew joined and then quit. Uncool Andrew. Where did you go, buddy? Or are you still there? Don't know. Hello, Debs. How are you doing? Hope everything's great in Brazil. And loop, column off, column 1. So we're going to go user define macro, and we're going to do alt 0, back to alt 0. Then we're going to do a loop. We're going to just loop 4 times. And we're going to call user define macro, and we're going to do column number 2. And then we're going to call everything off. And then we're going to call column 3. After column 3, we're going to then do another loop. Just loop 4 times. And we're going to call user defined function column 4. All right. Need a couple more vectors. Now we could wrap this all in a loop as well, which I probably need to do. Start loop. Yeah. Start loop. 99 times. Actually, I don't need to do that. Delete that. Yes. I forgot I can tell this to run repetitively. Column 4. And then we need to turn the column off. Use vector, column off. And now we're going to call alt 0, 1, 0. Did I goof up here? Yeah, it should be Alt 1. Right? No, shit. Column 4. This should be Alt 1. All right. Column off, Alt 1. Column off, Alt 0. Column off, Alt 1. Column off, Alt 0. Start a loop 4 times. Call function. And this will be column 5. And then we're going to call a macro, column off. And then we're going to call a macro and we're going to do Alt 1. And then we're going to do another loop. Do this 4 times. And we're going to call a user-defined function. This is going to be column 6. Almost done. Then I hook all the pins back up. All right. User-defined function. Column off. User-defined function. Alt 1. Nope. Alt 0. Alt 0, Bill. We need to add some more map vectors in here. And 4 times. User-defined function. And this one's going to be column 7. Now we're going to call column off. And then we're going to do nothing. All these can get deleted. All right. So there is our program. Now it's going to compile it. It's filling the memory of the pattern generator. And the pattern generator is currently generating this. So now we'll switch back over to the view. This one. Make sure we switch back microphones. You may need to readjust your microphone audio. We're going to need a power supply here. So you're going to need 2 power supplies. I'm going to set them both to 5 volts. All right. So we said pod 1. Just take my scope here. Has all the wires tangled up and everywhere. And I want to see if this guy here is ground. Well, I see data, but looks very weird on my scope. Oh. I'm looking at my scope. There you go. Just a little more. That didn't work. Feel free to make a donation so Bill can buy some real hardware. The goal eventually is to have this scope data actually captured. This is what happens when I was supposed to get a new camera mount for this, and yeah, Amazon F you. Okay. This is ground. Just want to confirm that this pin here is definitely ground. Right there. I made this pod number 3 was the row data. So you go here. You go here. You go here. All right. So, have you linked your Amazon to Twitch yet? If not, all you do is just, once you're registered on Twitch and you register a credit card, you just hit the sub button and you subscribe. That's pretty much it. Now, if you subscribe from your phone, which I strongly recommend not doing, Google Play or Apple Store will charge you additional fees. Because Google and Apple want their cut of the pay. So it's always recommended you're subbing from a desktop PC or Apple PC or a web browser and not on your phone and not through the store. If you have Amazon linked to your account, you can subscribe using your Twitch, your Amazon Game Prime thingy. However, you have to resubscribe every month. It does not auto-subscribe. That is a weird connector. That is round. Jeez, round. Fancy. So this is either going to work or not work. So I'm just now realizing when someone says something, I can actually hear like a chink sound in the background. I'm like, what is this noise I keep hearing? All right, so columns, or rows, columns, and this is the controls. So we take these two here. We're using 2 pins, and they will go on the bottom side right here. Don't really care which order. Alright. That should be all that is there. Now, we need power. Using my patented wire cutters as wire strippers. All right. We have equipment failure. What I'm going to do is grab 2 of these guys. This is the 5-volt one. What I'm going to do is take this one. We're going to hook this one up to the secondary power supply, because there's 2 power supplies. I don't know what for. So this one is, so we're hook up our ground first, and we have a new subscriber. Nope, new follower. Thanks for the follow, appreciate it. We are currently reverse engineering a LED display. So I am reversing a RGB or dot matrix display. I have several of them. As I drop my equipment on the floor, I have several of these. I have more of them in my workshop, in my garage storage bin area. So I am reverse engineering them. I've already gone through, traced out the basic schematic, looked up these parts. I am now using a Agilent pattern generator to generate what I think is the right signals to make this do something. It is currently sending signals in, and now I'm going to hook some power up, and either we're going to see smoke or we're not going to see anything. Well, we got lights. Yeah, my macro's off. What's interesting is when I change. So I think what I need to do is I need to flip these 2 pins around. Nope. So this is right, but this is wrong. That's right. So what's interesting, if I increase the current, why is or does this one go down and then this one go up? So I don't know where the orange wire is going to. The orange wire does not seem to affect shit. So the orange wire is just hooked to this big ass capacitor right here. So we're just going to tie these two together. Go like that. Now, we could be actually going too fast for the logic. We are running at 1 megahertz. But I'm definitely not seeing this one column here. So, yep, no. So this should be shifted that way. So it's almost like so this is, so I pull that high. So we need to figure out why that one column is not working. So what I'm going to do is I'm going to change the macro. I'm going to change those loops to 4 times, and let's see what happens. Back to desktop view. We're going to stop the pattern generator. I'm not sure what's that does to the over. So it shuts everything off. That's good. All right. So Alt 0, column 0, Alt 1, column 1, Alt 0, column 2, Alt 1, column 4, Alt 0, column 5, Alt 1, column 6, column 7. So we did all the columns, right? 0, 1, 2, 3, 4, 5, 6, 7. So what we could do is down here. There we go. How's that? That better? All right. As we would do on the Thug Shells stream, I muted myself. Yeah. I got 2 mics, so I could leave them both on, but I don't know how it might sound echoey. So let me know how that sounds. Let's change this loop to 8 times. Yeah, that's what I thought. 8, 8, 8. And what we need to also probably do is go into the clock, go into the sequence and go into the Alt 0 where we're doing this, and we're going to, hello DJ DJ Shinmu. How are you this evening? We are reverse engineering some LED boards. Let's do 0, 1, 0, 1, 0, 0, 0, 0, and then, so this will give us longer time for this to latch. And 1, 0, 1, 0, 1, 0, 0, 0, 0, 0. All right. Now let's go ahead and run this repeatedly. And let's see what happens. Let's see what that looks like. right, we're still missing that one row. It does look a little better. It's not as glitchy. We're still missing this one column. Hold on. How about we fix my microphone? So the good thing is I do have a new mixer on order, and the new mixer will fix this problem. So when I switch to this view, it will grab the correct microphone, and when I switch to the other view, it'll grab the other microphone. So instead of having 16 audio devices dangling off my computer with all this crazy different audio sources, I will have one audio mixer that will handle all my audio channels and properly process all my sound and everything. So hopefully, I don't even know if you even hear this. Hopefully I got that lock being cleared out of the mixer. It almost looks like a Space Invader. Alright. Or if you hold it this way, it looks like some adult phallic thing. Alright. Anywho. So I don't like the fact that it seems to be spazzing out. So let me do this. Let me just make sure. I may need to add some additional grounds here. All right. We'll go to. All right. This guy's grounded. This guy is not. Let's just grab. Let's grab number 0. It's this guy here. Down there. Then we'll just loop that right around. There. Didn't make a difference. Alright. So what I'm going to do is. That's that row. That's that row. That's that row. So the next one I pull off shouldn't do anything. Right. Didn't do anything. So this means I could have something wrong with my pattern generator. So I'm going to leave that one unhooked. I'm just going to take the one from the row before and hook it up. So it moved. Which basically tells me something wrong with my pod. So I will go grab another one of those. That might be bad, which sucks. Nope. Doing the same thing. What I'm going to do is I'm going to go in a little pattern generator and just output all ones. All right. Let's do stop. Yeah, that's what I'm going to do. So I'm going to go clocking. I'm going to do macros, and we're going to do add a macro and just do column FF and insert all on and sequence, and we're just going to do FF. It's probably going to look really weird. All right. As you can see, that worked. Still got a so the interesting thing here is I still got a dead. Yeah, I still got the flickering going on. So keep in mind, I'm running this at 1 megahertz, which is probably too fast for this display. Um, yeah, it's so. I'm gonna delete this. So I'm just gonna do column 1, column 0, column 1, column 0, column 1, column 0. Oh, man, what did I do? Alt 0, repeat 8 times. Alt 0. No, it should be all 1. Column 1. Alt 0. Column 1. Turn off that function. Let's see what that does. That is not what I expected. Oh. I Oh, we try that. Let's see what that looks like. My bits seem to be wrong. All right, let's do this. Let's go into macros. Alt 0. Let's just make it all ones. Actually, let's make this one all zeros. Oh, shit. All right, and then we go into alt 1. And we're just going to make this all ones. Right, that's right. All right, let's do this. Insert. 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 Alt 0, column 0. Alt 1, column 1. Alt 0, column 0. Alt 1, column 0. No, it's just going too fast. The problem is I can't change my clock frequency down. I think it's just too fast. And the thing is I think it's turning off all of the pins between sequences. So this is supposed to be. So what I'm doing here is I'm just basically doubling So my idea here was so when it stops, you can see it's clearly right. Well, not quite, but if I do that, and I change this one all zeros, that should be one row on, one row off. Well, that ain't right at all. See, I don't know why it's Alt 0 should be latching 0. Alt 0, column 0. Let's look at my column 0 macros. Column 0, shouldn't do anything with that. Column 1, column 2, column 3, column 4, column 5, column 6, column 7. Somehow, column 1, column 2, column 3, column 4, column 5, column 6, 0, 1, 2, 3, 4, 5, 6. Am I me or am I missing a column here? Yeah, but it's still not. My alt functions, like alt 0, Oh, I think I got it. Noob mistake. I wasn't latching off the row data. No, it's still wrong. Why is it not? It's not turning anything off on Alt 0. Alt 0 is supposed to be turning stuff off. I have Alt 0 here, Alt 0 here. The 0, 0, 0, 0, 0, 0, 0, 0. Let's see what that does. Alt 1. All right, let's do this. Let's just change these to 0, 0. Should never latch a high on the which is doing. That's working fine. Let's do this. Let's go over to Alt 1 and just change this to all right. This should be the next row. Right. I think he's just going too fast. This should be the next row. I wish this did cell copy. I don't need to latch all this crap. This should be the fourth row. There's the next row. That's the next row. So let's do 1 0. Let's just do my alternating thing. 1 0, 1 0, 1 0, 1 0, 1 0. 1 0. Right that. So that should be every other row. Right. Oh. I think I know what it is. I wonder if I can do this. Oh man. Can I call a macro from a macro? It'd be cool if I could copy this macro into another macro. So I think my problem is I am trying to do too much at once. So here, let's do this. So I'm gonna do a loop. I'm just gonna loop 99 50 times. And then what I'm gonna do is I'm gonna copy this whole loop over. Yeah. This time I'm gonna do Alt 1. Just use Alt 1. I'll go up here, change these to Alt 0. And I also need to copy this. Paste on here. Alright, now I'll go into my macros. Go to delete this macro. Get rid of that thing. Go to Alt 1. 1, 1, 1, 1. So now Alt 0 is that way. Alt 1 is that way. So now, if I run this repetitively, it might be still too fast for our persistence of vision. Yeah. That's why we're seeing flickering, is because it's going so fast. So what I need to do is change this to 99. But inside here, we'll start another loop. And we'll go another 99 times. All right. So it's going to loop 99 times and then 99 times. So it's 99 times 99 loops at 1 megahertz. Better? How is that better? Move? I ain't seen shit. Okay, what I need to do here is I'm leaving column 7 on when I enter the loop. All right, I can see it working now. Let's do this. Let's take out this extra loop. So here's the funny thing. You can see it on the camera. I can't see it with my eyes. So the camera is actually seeing this. I can't see it. to me, they're just glowing very dimly. But yeah, you can see it's alternating between the two. So I had the logic right. So I think I did. The problem is I need to draw a line. I need to add some delays in here before I can move to the next thing. This is just going too fast, unfortunately. But good thing is we only need to add five. It runs on 5 volts. Um, Solid 5 volts, which is good. So I think the next step will be to actually make an Arduino drive this. Yeah, we've and it's looking at it this way, it just looks like it's constantly on, but it is flicker. It's basically drawing each line and going back and forth. The problem is my equipment's running too fast. It's running at 1 megahertz. This is obviously needs a lot slower refresh rate, which is going to be tricky because it's not like you can latch all the data and it's going to show. I'm going to have to make a dedicated routine that's all it's going to do is update this display. And I need to figure out the optimal refresh rate for each. I'm trying to get it to display 2 different things, which I don't have my pattern logic set up right to do that. But my goal tonight was to be able to drive this, reverse engineer it, and then use the pattern generator to draw something, which clearly I have done. Just not as well as I would like it to. I need to add some delays in here. So what I'll do is this. Hit stop. Of course, you probably didn't hear a single damn word I said because I had the wrong microphone turned on. So I'm going to do is I'm going to create a delay function, macro, and we're going to call it delay. And we're going to insert a loop. This is an illegal condition. And we're going to create a loop, and we're going to loop 99 times. So this is just a delay. Then we're going to go back over to sequence, and we're going to go Alt-0, set column data, and then we're going to insert a line, and we're going to call that delay function. Then we're going to do the next column, insert delay, insert delay, insert delay, insert delay, insert delay, insert delay, insert delay. Let's see what that does. All right. So now I'm going to stop this. I'm going to delete all this. Yes. Then we're going to just copy this whole thing. And then we're going to paste it. And then we're going to change this to Alt-1. And then we're just going to add 2 delays at the very end. Same thing here. Insert, insert. Delay. Delay. All right, let's see what this looks like. Yay, I think we made 2 steps backwards. Well, that just sucks. Let's do this. Let's make a new macro. And we're going to call it super delay or delay 2x. And we're just going to go insert, insert, insert. And we're going to do a user defined macro. We're going to call, oh, nope, cancel. We're going to do a loop of 99 times. Oh, we can do 100. And we're just going to call the other delay loop in there. And then we're going to this sequence and we're going to call delay 2x. Take this line out. Call delay 2x. Take this line out. And then run that. Let me get rid of all this. All right, let's do this. Insert and user defined macro delay 2x. Yeah. User defined macro 2x. All right. Well, if you needed an epileptic seizure device, it's almost like I need a loop to go back and do all this, like put all this in a loop, but I can't start a loop and move the, like it says end loop. I wish I could go in and say, Repeat 8 times. I think I got the idea of how to program this. So I think the next step will be using an Arduino. So next Monday we will attempt using an Arduino to drive this, and we'll do some Arduino code. Now that we got this figured out with a pattern generator. Fortunately, this thing is just way too fast. I mean, we could crank it all the way up to 180 megahertz, or better yet, we'll just go to half channel, and we'll just push it all the way to 300 megahertz. Yeah, the Arduino will be slower, a lot slower, and it'll be easier to add loops and delays. That, and we're only going to be. See, I'm trying to alternate between. The thing here is we're trying to display a character in one section of this. Trying to display one character, and then we're trying to display another character. So if I take all this out and I run this, we can see what we wanted somewhat. So save this configuration. Macro setup only. So I'm gonna call it a night. Let's see if we can raid anybody. Let's see who's online. Let's see here. Da 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 da. We need to go to a different view. Back to Twitch. Go back to my channel. Moderator view. Let's see here. That's raid egg. Let's go read my friend Ego. Ego Walio. All right, Ego's cool. Let's watch Ego for a little bit.